All right, hey everybody, welcome back. So this is part two of our mini project building a virtual canvas installation. So before we jump into things, let's take a look at where we left off. So here's our overall project. We have our scenes. In this case, we just have two noise scenes, super simple. We have a virtual canvas that we'll come back to. It has a X bounds that represents our render viewport, and then a resolution, and then we have some post that we haven't done anything with yet. Inside our virtual canvas, this is where we are doing kind of the meat of our work. We have a very simple render setup, and we have this tiled grid geo. This tiled grid geo, we have an instanced quad array, and that will allow us to change the shape and the density of our grid. And then we've done some texture mapping work so that we have our texture, input texture, neatly mapped onto all of the mosaic tiles so that we can also then recreate kind of a perfect flat image when we desire. In addition to doing things that we're going to explore in this section, which include adding distortion, some different types of transitions, and some other cool stuff. So I think the first thing that I want to do is add just like some noise, just some classic noise as a layer to give some interest to our visual here. Now, there's a couple ways that we could do this. We could add our noise and just kind of say grab the resolution from this UV input and there we go. Just kind of use the noise to distort the initial position. That is actually not too bad. I'll customize my parent component and I will say turb speed. I'll add a float there. Then I'm going to get a parameter. I grab that turb speed that I just created. I'm going to add a speed chop on the end of it, and I'm going to add a null. I will rename this to turb speed. And I guess for good order, I'll toss a rename in here too, and I'll rename this channel to speed. Then I'll, whoops, speed. Then I will drag and drop this on my noise translate. And for those of you just tuning in, these buttons that I use up here, that's the function store toolbar for TouchDesigner. You can grab it from his Patreon, or it's floating around the internet too. TouchDesigner also just released an official write-up about it on their website, so you can check that out. All right, so there we have our speed parameter. I like using this kind of network instead of using the abs times seconds translate because it gives you a little bit more control. And then you can really start to kind of fine tune exactly how fast you're moving in addition to stopping at any moment without resetting, which is pretty handy. So we'll give ourselves just some nice like wavy turbulence here. Now this is okay. We'll make the offset 0, amplitude 2, 32-bit float. Okay, that's all great. It's fine. It's not looking too bad. Turn it off, turn it on. Okay, that's nice. Maybe drag and drop my amplitude so that I now have an amplitude parameter that I can play with. Not too bad. However, I think that this becomes somewhat, I don't know, not enough, boring, whatever the right word is. It's just not really that interesting. And I think one of the things that is uninteresting about it is that it's kind of just the same, going across the entire canvas. And while it's moving the position, our tiles aren't really changing size. So one thing that we could certainly do, and this is what I'm going to do right now, is if we look here, we're just adding the noise. So I'm going to kind of refactor out this noise. I'm going to take the noise. I am instead going to do an add right here and make sure that that noise is set to a 32-bit float and that the add has a fixed input 1. We then need to turn this input to just noise so that we're not adding it twice. And now we have a nice noise. And actually, I'll just change it to custom resolution and drop my grid res on there. Although you'll notice, because we're using it as a lookup, we don't actually have to do that. But yeah, we may as well. To minimize our calculations. And then we can unhook this, and I'll add a null here and call it turb. We will also turn off monochrome, and that will remove some of the weirdness. Okay, so that's not so bad. I'm gonna turn up the gain a little bit and maybe the spread to like 3. So now, based on our amplitude, things will start to get a little bit crazier. That's obviously personal preference. You can really do whatever you like there. But I like when it gets a little bit bigger, how you actually have some difficulty telling that there is structure involved. And then I'm also going to increase the period to like 3. And I think that's pretty good. Now, at this point, I really can't help myself. I'm going to go in here, and I'm going to select, and I'll go up a level, and then I will go into my virtual canvas component, and then I will grab that component that I just made. Turb, although virtual canvas. Aha. So that's what I want to do probably. I need to grab it from inside this tile grid geo. So that should go here. Virtual. Okay. Fine. Sometimes doing it the long way actually saves time. So I'll drag and drop that turb, and then I'll use that instead of my other noise. Ooh, okay. I don't really like that so much. Oh, probably because of the offset. So I could add, with my math, I could just add 0.5 to get that offset back. And then, I don't like that, though. Yeah, that's not so great actually. I wanna, maybe I can use this like this. Somewhat interesting. Output, input, times noise. Okay, so actually I think maybe this should work nicely. Yeah, okay. So now by adding a half there and the offset, and then I'm using it as a multiplicative input to this other noise in my effect. So now my colors are somewhat related to the distortion that's occurring, which, well, I don't know, looked cooler in my head. So, fuck it. Never mind then. A little bit of an aside. So, I take that back. And we'll go back here to our turbulence. And so, all right, we've got our added turb. Now, if we want there to be some sort of like optical flow or forces or I don't know, just anything that's more than this kind of noise-based turbulence, we're going to need some feedback. And what we're basically going to do is just write a little simulation that's going to use initial positions to basically have like a home, and it'll reset the particle positions to their home over time. So I'm going to start by adding a vector and then 1 over me dot time dot rate. So this will be by like dt time step. And so what I'm going to do here is basically add a feedback. That feedback we can call pose, and that'll go in my first input. I'll drag and drop this null out there. And now my initial positions will be my second input. And then this add I'll rename to velocity, and that'll be my third input. So then this can be tile sim. Yes, sounds good. And now we can edit. So we can have a uniform float, U delta. And then in here, we can start to just write a little bit. So first we'll define our inputs. So I'll define my pose input as 0. I'll define my initial input as 1. And I will define my velocity input as 2. Then we can start to read in our data, getting our position and our initial position using our position and init lookups respectively. And then I normally just set the set the z component to 0 for the initial component. Now we will read in the force. So effect for velocity is equal to texture std2d inputs 0, but not 0, actually velocity vuv.st.rgb. Now we will create a vec3, we'll call it force, and we will set it equal to velocity. Actually, I think first we should set it equal to 0 to initialize it. get force, and then we can do force plus equals velocity times RU delta, so that's one time step. And now we have a section for return to initial position. And so here we're going to apply some force that will return at home as our external force dissipates. So to do that, we can create a vec3, call it direction home, and that will be equal to its initial minus its position. We can then add to our force this direction home vector times our u delta as well. And then we can add to our force z component the length of the force. And in this way, we will add some sort of z-space dynamic that will allow us to just add a little bit of visual interest. So, the further away you are from your home position, the bigger you are. Then we can apply force to position, and that is just pose plus equals force. And then we can just output our position. Let's see what our errors are. In line 21, we cannot convert from vec3 to vec4, so I just need to grab the vec3 components of those. And the same thing on 26. So that should be pose.rgb plus equals force. And awesome. So there we have it. Well, kind of. Something is happening. Our simulation is working, but it's not quite functioning as expected. Let's see what happens when we turn our noise the whole way down. Okay, so I think we should probably not have the velocity be the added to the position anymore, so we should just make that a null and then use just our velocity. Okay, so now our sim is working a little bit, and okay, so we are indeed adding over time some amplitude, but it seems like it's a little bit unchecked at the moment. So let's see. What do we think is going wrong here? Feels like something to do. We'll make sure we're on 32-bit float for one, but I don't think that's it. So because we're just adding a ton as soon as we turn the amplitude up a little bit, it makes me think that I am doing something with my velocity here a little bit wrong. I think maybe I'll try to normalize it and see if that does anything. Did not do a ton. Okay. I guess you can normalize a vector of all zeros. Interesting. Okay, so why is this not working? Um, Okay. I think that this should not be direction home, but rather force XY. Because if I'm adding direction home, then that means it could potentially be in like world space and gigantic. So let's see if that fixed anything. Ha ha ha. Okay, amazing. Now things are much more controlled. Um, it's crazy what such a simple thing can do. All right, so now we have this like little feedback effect applied on our position, which is cool because it keeps things moving really smoothly. And it will also allow us to do some crazy stuff like displace for a period of time and then have our positions kind of like fall back. So let's think maybe what's an easy way to do this? So we can do a mouse in. I will just like really quickly remap this. So tx from -3 to -1. And then, whoops, -1, -3. And then we have ty minus 5.8 to 5.1. So minus 0.58 to 0.51, and that'll be just ty. Okay, so we have our little mouse mapped, and then what I'm going to do here is, whoops, just add another math, and it's just going to rearrange it from 1, 1 to minus 0.5, which is going to make it nicer to use for a circle. And then what I'm going to do is just drop down the circle, use ty and tx for the center, make it like way smaller. Like that, and then set its resolution to that resolution, but I don't want to bind it. I just want to reference it, and we'll make sure it can be 8-bit. Okay, so now we have this, and possibly one thing that we would want to do is just like kind of use our mouse to apply some displacement to our field here. So we would probably want to do that by adding something here to our turbulence. That doesn't seem to be doing a ton. Actually, we'll have to make sure that's input 1. If it is. Aha! And now it's subtle, but it is happening. So we'll make our circle a 32-bit float. And then, what can we do? We can take this noise, multiply the circle by it, like this, make the period, or turn off monochrome, make the period somewhat larger, and make the amplitude like 4. And make sure it's 32-bit float. All right, so there you go. And now you can start to move around some of these tiles with your mouse. There's obviously better ways to do this. You could look at an optical flow algorithm. You could, I don't know, do it any one of a number of ways. This is just a quick kind of proof of concept to illustrate how you could think about adding some interactivity. I've got a ton of other tutorials on specifically how you can add interactivity to simulations of this style. So I'd take a look at those if you're interested in digging in more there. But for now, I think this is a good kind of use case demonstration, and we can see that once our mouse moves, and maybe we can do one thing, our left button we can grab with an L, and then what we can do is take that and make our fill alpha. So now our mouse only shows up when we click, which is definitely pretty nice. And by the way, if I were you, I would be, whoops, dropping these guys down to a little base that I would call like mouse draw or something like that. Because it's pretty handy to have a mouse input that you can just like use for quick testing. So at this point, we've now got the ability to add kind of amplitude across the entire thing. We've got the ability to add extra with our mouse. And we can still add a bunch of tiles and change the size. I think we probably want to have the size change a little bit though, based on the distortion or something along those lines. Just so that there's a little bit more variation in the scale here. Our scale is all still pretty constant. And so maybe something that we could do is take our math top and we can look at combining channels with the length. And then we can take a look at what those channels look like. You can see that our R and G values don't look super interesting. I mean, it's actually R is kind of interesting because of the distortion. But I think what we probably want maybe is like this B value, which is going to be our Z distance. So what we could do pretty easily, I think, is just remap that Z distance. Let's say first by doing the order, getting just the blue. Then we can take a limit. And just by looking at it, I can see that it's kind of going from like negative 10 to positive 10-ish. Not exactly, but you know. What can be exact? Negative 10 to 10. And then from there, I will add another math and I will rearrange this from my limit minimum to my limit maximum, just like that. And then our range, we can do from 0 to our tile size times 2. We can use that for the scale instead of our constant. And so now when our amplitude is 0, we kind of return to this base tile size rather. But we see that there's one, a lot more variation being added from the distortion. And 2, when we distort across the entire structure, then we start to see more of this interesting variety in our tiles. And then we can also make it like, smaller if we wanted to when the tiles are distorted. Like you could have the size be a function of amplitude or something along those lines. But this is starting to look pretty cool. And if you get crazier, you still end up getting some very smooth motion because of our little feedback system. So I'll bring these back, something like that. Um, yeah, and so there we have some cool distortion that is working pretty well and impacting our scale, which is a great start. Okay, so that is pretty solid as far as a single one of these grids and rendering it. So we can clean things up a little bit here now. Add back some of these boxes that I took. Get a select. Scale. And then this turbulence can just kind of be one section, which is turbulence, and then we will move our little sim loop up here, space things out a little bit, and there we go. So simulation, got our background. Oops. Okay, so thank you for bearing with that. So now we got a little bit of a cleaner setup. So at this point, what we can do is add kind of our final aesthetics and have a really nicely rendered single tile for one of our, or single tile grid for one of our things. So what we can add first, very simply, we can just add a noise, a null, and then we can do an add sop, geo, turn on instancing, add a convert here. And those of you who have followed my other tutorials will see that by converting to particles per point and adding a point here, I'm setting up a point sprite rendering network. And then we can turn on our instancing and use this null one to translate a bunch of our instances. If we set our amplitude to double our x bounds, and we turn off the render of our grid, You can see that we probably need, yeah, some pixel format help. So there you go. That is some quick dust motes. We can now transform 0.01, something like that. If you don't want to use simplex noise, you could go into the palette, and where is it at? It is... Aha, the noise generator. I always forget. I believe... Nope, they don't have curl noise there. Okay, well, you can find curl noise if you like, and it's a little bit more aesthetic here, but doesn't really matter in the grand scheme of things. So cool. Now we've got all of this dust moving around. I'm going to attenuate my point scale, and I'm also going to use a circle with some softness as my base for rendering. Turn on blending and off depth testing. And then back to my scale. My attenuate near distance is going to be my x bounds. Oops, not scale, but my near distance. And my far distance is going to be double that. And in this way, I'm going to achieve a nice distribution of size, where there's some that are really far off in the distance and some that are much bigger. That near scale, then we can make whatever you want. I like maybe something around a 3. Then what I'm probably going to do is grab a render pass, and I will render just my grid geometry on that render pass, and then I will render just my dust geometry on this render pass. And we can just turn on our clear to camera, and now we just have our dust. Now, I'm not going to go through how to build this one, but those of you who are on my Patreon, you can grab this texture 3D feedback. There's also a tutorial that I have that I can link that goes through how to build this yourself, so you don't need to pay for it if you don't want to. I think it's important to be able to get there yourself with no money if it's something you're interested in. So you can go check that out, but I'm just going to drop it in here and then use my over. And so maybe if I add a transform, turn on comp over backgrounds. I like to make these just a little bit non-zero, something like that. There you go, and all of a sudden, we have some nice points moving around in the background. Maybe make them, ooh, no, too big. Too big. which just adds a little bit of visual interest. Now, if you want to add something like a frame, you could certainly do that. There's several different ways that you could do so. I think that it kind of depends. You could do it in post, you could do it not in post. I think the way that I would probably do it in this case would be something, well, while we're here. One thing I do like to add in post is if I change this to random, change the seed to be me.time.frame, and then change the output to be input minus noise, the offset to be 0, the amplitude to be 0.2, and then this noise scale set at something like 0.1, which adds just like a really subtle grain over the top, but I think is pretty nice and helps a little bit if you're going to be exporting and like compressing and stuff. So if you wanted to add a frame, I would probably maybe look at doing something like a box, and that box we would want to make the size x bounds by x bounds times parent parent.canvas.par.resolution2 divided by parent.canvas.par.resolution1. And then z, I don't know, make it like 10. Now we can go in here and we can use a delete SOP. And if you turn on display options and turn on primitive numbers, we can see that primitive 0 and 2 are the two primitives that we don't want. And then if we delete them, we're left with a frame. So that frame we can attach to a geo. And we'll just do another render pass. And that render pass, we will render just our frame. We will clear our camera again. That frame does not seem to be rendering. Should probably put a material on. Although I don't think that's everything. Aha, there it is. We can see part of it. And now we can see most of it. We need to clear the depth buffer as well. And then we can see that it needs to be bigger. Now we can add another over to get this frame into the mix. And then maybe instead of x bounds, it's x bounds times 2. Boom, there you go. And now we can increase the width a little bit or increase the height or the size a little bit, depending on what you prefer. And then this width you can still increase. And there you have a frame. We could make it a Fong material instead of this other material, and what I might do is use some, again, like a random noise, low, or period 1, kind of low amplitude. Just drop that on as a color map. And then what we can also do to get it brighter is add a new light. And this light will be only for render pass 2. And the other light will be for render pass 1. And then this light will be both closer and angled. And you can also kind of see what that might look like on render 1, although the effect isn't huge right there. And so now we have this frame, and everything else is kind of working as we would expect. If you wanted this over, like the frame over top, we could make it over top by just reorienting that over. And then you can probably much better see the light shifting on the frame as I turn this, which is also pretty cool. You could, of course, also make this like a PBR, all sorts of different things, options that you have kind of once you're going. And so there we have kind of a lot. There's one thing that I'm going to do before I stop here, and that is just take this turbulence and export it. So instead, we'll have an in with a null, and we'll drag and drop that. In turb. And then I'm just going to copy this entire thing, or cut it rather, and put it up here. I need to add my turb speed parameter back. And give it some speed, which is great. And then I'm going to do the same thing with amplitude. Now, the reason that I'm just doing these again is because I'm going to, in the next part, have multiple what do you call it? Multiple grids that are being rendered all at the same time. And so I want to have this turbulence be something that I can use across all of the grids because it's pretty cool when they are moving together. So I will just select this turb and put that in there. I'm going to take my mouse out for a second and just turn up the amplitude here. So, all right, now I'm feeling very good about all of this. We kind of have a good little setup here. You can call this render with all of our lights. We've got our post-processing going. One thing that I might do to clean all of this up would be to just put all of this stuff inside make sure I turn on those render flags, and then we just have to point these guys inside, and boom, we got our dust motes back, and now it's just like a nice little geo. We can do the same for our frame by just pasting these guys in here, just like this. Make sure to turn on the display and render flags. And then all we have to do for this one is update our material. And so now we have our geometry kind of all nicely organized for us. Geometry. And yeah, we're really making some progress on this build. So from here, we'll be doing one main thing, which is adding the capability to transition between two of these grids using some advanced rendering techniques. And then after that, we are going to be doing some experimentation and kind of more, let's say, fun extensions. One quick note, because I forgot to mention it, all of this weird flickering, if you like it, cool. If you don't and you want to fix it, what you can do is go into this material, go into common, turn on blending, and then turn off depth testing. Oops, depth testing off. There you go. And that takes care of that flickering. So now it's nice and smooth and pretty cool. All right, so this is a little bit longer than I wanted it to be. I'm going to take a stop there. Thank you all for all the support and for the interest. I hope you find this helpful. And until next time, good luck out there.